Hello students, now we will be solving memory-based questions of GATE 19. For more video solution on GATE 19, subscribe to our channel and don't forget to click bell icon for instant notification.
Hello students, I am Abhijit and here we will be solving the question of engineering mathematics from the chapter calculus. So the question is, we have been given the functions, okay, so x is equal to psi ln phi and y is equal to phi ln psi. Then we have to find the partial derivative of psi with respect to x. So here are the options, and it is a very good question. If we are good in the fundamentals of differentiation, then this question is very good. Okay, so let us solve the question. So here what we can do, we have to find the psi with respect to x. So we will find out the psi in terms of x. Okay, so from the equation 1 we can write the psi is equal to x divided by ln phi. Okay, now we know that here y is also a function of phi and ln psi. So definitely we will put the value of phi from here because we want to convert our psi in terms of x and y. Okay, so definitely here we can write this as ln phi. Ln phi means ln y divided by ln psi. Okay, so here it will be x divided by ln y minus ln psi. Okay, so here we got our function in terms of x, y and psi. Okay, now we can differentiate these with respect to x by keeping y as a constant, because this is a fundamental of partial derivative. Whenever you are differentiating any function with respect to x partially, then definitely at that time the other variable is constant. So here if we are differentiating the psi with respect to x, definitely here y will be constant. Okay, so here one thing we have to keep in mind, either x is a constant, x is a variable, sorry, and y is a constant, but here we are having psi and we know that psi is a function of x. Okay, so here there is a function of x, there is a function of x in numerator and denominator, both the sides. So definitely we will apply a division rule of derivative. So what we will do, we will leave this function and we will leave this function and we will differentiate it. We will get 1 minus, we will leave the x and we will differentiate this function. The ln y will be 0 because y is a constant, and here we will differentiate this and we will get 1 by ln psi. Now we will differentiate this ln psi, that will be 1 by psi. Okay, now again here it will be del psi by del x because chain rule is there. Okay, so and here in the denominator we will be having ln y minus ln psi whole square. So we got the expression, a big expression we got. We can simplify this expression by looking at the options. Okay, so we know that this much expression can be reduced. This expression can be written as ln y minus this. We know that ln y minus ln psi is nothing but x by psi. So we can replace this and we will get, it will be nothing but what? X by psi, this whole value, minus, this is minus plus, and x divided by psi ln psi, and it will be del psi by del x. Okay, so this much expression we got, and in the denominator also we will get x by psi whole square. Okay, so x by psi and x by psi can be cancelled out, taken common and can be cancelled out. Okay. So here del psi by del x y is a constant, can be written as now 1 plus 1 by ln psi del psi by del x divided by x by psi. Okay, so here we will take this, we are very close to our options now. We have to just put the values here. Okay, so what can we do? We will take this here, x by psi, and we will take this term because we want to evaluate the del psi by del x from this expression. So we will take here, just a simple manipulation is required here. It will be 1. So del psi by del x is taken common. Here it will be 1 by x by psi minus 1 by ln phi. Okay, so we are very close to our options now. Del psi by del x is equal to 1 divided by x ln psi minus psi, and in the upper side it will be x ln psi. Okay, by taking LCM we will get this expression. Now we are very close here. See, phi here, x can be replaced, and x is what? X is equal to psi into ln phi. So del phi by del x is equal to psi ln psi, and x is equal to psi ln phi and ln psi minus psi. So psi will be cancelled out, and we'll get 1 here, and we got our expression. So see, this is the expression which is in the option B. So our correct option is B. Here the correct option is B. So finally we got the answer. So I hope you liked the video. Please don't forget to like and share the video with your friends. Thank you and all the best.